Welcome to solverfy.
Alright, so for this problem, they are wanting us to find the volume in liters of nitrogen dioxide from this chemical equation with a couple of notes that they give us. One of the first conversion factors that I'm going to use is 1 torr is going to equal 0.00131.579 atmospheres. So we're going to be using that later when we use our PV is equal to nRT. Alright, so a couple of the knowns that they give us are our pressure. So they say that our pressure is equal to 735 torr, and I'm just going to convert that right now. So we're going to do 735, and we're going to times that by this 0.0131579. So our new pressure is going to be 0.9671 atmospheres. They also tell us that the temperature is 28.2 degrees Celsius. I'm just going to add 273 Kelvin to this to get it into Kelvin. So our new temperature is going to be 301.2 Kelvin. And I'm going to be using R is equal to 0.0821 liters atmosphere per mole Kelvin. And we are looking for volume in liters. Alright, so to first start this problem, we have to figure out what our limiting reagent is, whether it be the copper or whether it be the HNO3. So to do this, they give us a volume for our copper. So we're going to figure out the moles of copper. And they tell us that our volume of copper is 4.95 centimeters cubed. And they also give us the density of copper, which will help us get the mass of our copper. So our density is 8.95 grams per centimeters cubed. So centimeters cubed cancel out. So we get 44.3 grams of copper. To get the moles of copper, we just take 44.3 grams and we divide it by the molecular mass, which is 63.546 grams per mole. And this gives us 0.6985 moles of copper. Alright, and then now we need to figure out our moles of HNO3. They give us our volume as 230.0 milliliters. They also give us the density for HNO3, and it is 1.42 grams per centimeter cubed. Just to note, milliliters, or 1 milliliter is equal to 1 centimeter cubed. And then they also tell us that it is 68% of its weight, so we are going to do 68 over 100, so that way we get the correct moles. Alright, so again, these two are going to cancel out, and we are going to get 3.525 moles of HNO3. So by looking at the moles of copper and HNO3, our copper is our limiting reagent. I'm going to just label that LR. Alright, so now that we know our limiting reagent, we can find the moles of nitrogen dioxide. So moles of nitrogen dioxide, and we're going to use the moles from our copper since that's our limiting reagent. So 0.6985 moles. And if we go back up here to our chemical equation, we see that when we have 1 mole of copper, we get 2 moles of our nitrogen dioxide. So we are actually going to times this by 2. And this is going to give us 1.397 moles of NO2. All right, so then we're just going to use our PV is equal to RNT, and we're searching for a volume, so V is equal to nRT over P. So our volume is going to be our moles of nitrogen, so 1.397 moles. And we're going to times that by our R value, which is 0.0821 liters atmosphere per mole Kelvin. And we're going to times that by our temperature, which is 301.2 Kelvin. And we are going to divide all of this by our pressure, which is 0.9671 atmospheres. So when we calculate all of this out, our new volume is going to be 35.72 liters of nitrogen dioxide.